Let me make a quick revision to differentiate between the metals and the nonmetals by just observing their physical features. The physical feature, it's just the physical appearance. We didn't get into the chemical structure or the chemical composition of the element, but just observing how it looks like, what is the physical appearance of each one of these categories. We will observe that all of the metals, they have a metallic luster. The word luster, it means brightness. So to be bright, so it means that it's a metal. But all of the nonmetals, they are dull. What's the meaning of the term dull? So it doesn't have that metallic appearance, and they are non-bright. All of the metals are solids in the physical states, except one metal existing in the liquid state known by mercury. While for the category of the nonmetals, they could exist into either the solid form, like phosphorus, like sulfur, like carbon. We have some liquid forms, and the only liquid nonmetal is bromine among the halogens in group 17. And some of them are gases. We couldn't find the gas representing a metal. Never existing. So all of the gases, they are related to the category of the nonmetals, including oxygen, chlorine, fluorine, all of the gases existing in atmosphere. So this is related to the physical state. All of the metals, they are malleable. Malleable, and it means that they could be bent without being broken, and we could shape them. So they are deformable. While all of the nonmetals, they are non-malleable. So if we try to bend or shape any one of the nonmetals like glass, like bricks, like plastic, it's going to be broken. So we couldn't shape them. Metals are ductile, so we can twist them and insert them into wires. While we couldn't do this with nonmetals, so all of the nonmetals are non-ductile. Also, we have essential features like being good conductors of heat and electricity. And here they are bad or poor conductors of heat and electricity, and that's why we call them insulators. All of the metals, they have high melting and boiling points. While the opposite will be observed among the nonmetals, they have low melting and boiling points, okay? Let's complete here. Okay, the melting and the boiling points, they are the temperatures where the matter start to melt or boil. So whenever, if you have any piece of metal, if it's heated to an external temperature, it changes from the solid state into the liquid state, and the temperature at which that metal starts to melt, it's known by the melting point. And if we continue heating, so that liquid starts to evaporate and change from the liquid state to the gaseous state, and it starts to boil. And the temperature at which that matter starts to boil and change from the liquid to the gaseous form, it's known by the boiling point. So all of the metals, they have high melting and boiling points. If we have a piece of copper or a piece of iron and we need to melt it, so it has very, very higher temperatures that might reach to 3,600 degrees Celsius and above. Or the nonmetals, if we have a piece of plastic and we need to melt it, so very, very low temperature is needed to melt that plastic piece. Let's start to know more about the features of the metals and the nonmetals throughout these activities. So as we discussed that all the metals are solids except mercury, and the symbol of mercury in the periodic table, it's Hg, and this is the only liquid metal. This is the shape of the liquid mercury that's used in making medical thermometers, because as it's a metal, it's a good conductor of heat. So whenever we have any fever, so the internal temperatures of our bodies are high, and accordingly that mercury will be expanded according to the internal temperature of the body, and it gives you the accurate temperature of that sick person. So mercury existing in the liquid form, as we have here into that figure, while nonmetals are either solids or gases, as we explained in the previous table, except bromine, it exists into the liquid form. So this is bromine. So two liquid matter we have among the metals and the nonmetals. The only liquid metal is mercury, and the only liquid nonmetal is bromine. Let's, in this activity, discover and collaborate with your classmate to discover the differences between the metals and the nonmetals through studying the figure from. We have here a piece of sodium. Here we have graphite or carbon. Here we have sulfur into the solid form and copper. And here we have parts from the electric circuit. Let's start from the figure here, 3 and 4. As we said that this is sodium and this is a bar of carbon or graphite. Which is the metal and which is the non-metal? From the physical features we discussed before, which one has a metallic luster, has a metallic appearance, has a shiny brightness? So you will observe that sodium as a substance that has that metallic luster, so it would be considered as a metal, while carbon, it's dull, it's black, it doesn't have any metallic appearance, and that's why it's a non-metal. So which is the metallic element? It will be sodium. And which is the non-metallic element? It will be carbon or graphite. So the metallic element, it's sodium because it has the metallic appearance or brightness, and the non-metallic one will be carbon.
تقدر تتابع كل دروسك على تطبيق مدرستنا بلس. مدرستنا، المستقبل يبدأ الآن.